In addition to practicing evaluating expressions, it's important to practice building expressions using Boolean operators. Let's do a few examples together. In these examples, we're given a problem statement. Our goal is to create a Boolean expression that captures the logic needed to make the decision described in the problem statement. Let's read the first problem. A person should get a COVID test if they have a temperature of 100 degrees or more and have a cough. Write an expression that's true if a person should get tested. Our first step in these problems is to identify the variables that are needed to make the decision in the program. In this case, we need to know both the temperature of the person and also their symptoms. I'm going to create two variables, one that is a temperature and one that represents symptoms. My next task is to think about what data types would make sense for these two variables. Because a temperature can have a decimal value, I'm going to use a double data type as the storage for my temperature. And because my symptoms can include a phrase or a statement like cough, I'm going to use a string data type for the symptoms. Now I want to write the Boolean expression that captures the logic of making this decision. I know the decision is dependent on both the temperature and the symptoms, and we want to write an expression that's true if a person should get tested. A person should get tested if their temperature is 100 degrees or more. So I would write that using the relational operator greater than or equal to 100. And then I also want to consider their symptoms. And remember, I need to use the dot equals operator if I want to compare two string values. And now I need to consider what logical operator should join those together. I should get tested if I have both of these symptoms. And so I'm going to use the and operator to join those together. Let's try another example. This problem statement says a restaurant gives a discount to any delivery customer that orders $50 or more of food and at least 2 desserts. Write an expression that's true if the restaurant should give a discount to a customer. So again, my first step is to think about what variables are involved in making the decision. In this case, it's the total cost of the order and also the number of desserts. Next, I need to think about what data type would be appropriate for each of these variables. The total cost of the order could possibly include dollars and cents, so I'm going to use a double data value for that. And the number of desserts is going to be a whole number. Most restaurants don't allow you to order half of a dessert, so I'm going to say the number of desserts is an integer. Once I have my variables identified, now I'm ready to capture the decision-making process in my Boolean expression. In this case, I want to decide, should the person who is placing the order get the discount? And they're eligible for the discount if the total cost of their order is greater than or equal to 50. And also if the number of desserts is, if it's greater than or equal to 2. And then finally, I need to decide what logical operator to use to combine together those two answers. And because we want both of those things to be true in order for somebody to be eligible for the discount, we're going to use the and operator. Let's further investigate the rules that are used whenever Java evaluates expressions. Java uses a technique called short circuit evaluation as it's evaluating logical expressions. This means that logical expressions are evaluated left to right, and that the evaluation stops as soon as the final truth value can be determined definitively. So if there's any question about whether the final answer is true or false, Java will continue to evaluate the expression. But as soon as it knows the final answer, it will not evaluate any other portions of the expression. And this is a time-saving mechanism. It allows it to save time by not wasting time evaluating something that doesn't actually play into the final decision. Let's see how this works. Suppose that we have 3 variables in our program: an age, a height, and a weight. Suppose that we're evaluating this expression, checking to see if the age is greater than 50 and the height is greater than 60. When we're evaluating this expression, remember the first step is to fill in the value for variables, pulling those from memory. So we're going to retrieve the value of age, and that's 25. I'm going to write those all out first. And I also need to retrieve the height, that's the 70, see if it's greater than 60. Now I need to evaluate the expressions And I'm going to move from left to right. So first, I'm going to evaluate the expression in this first set of parentheses. I'm going to ask myself, is 25 bigger than 50? And that is false. And now let's think of how the AND operator works. Suppose that we have two operands for the AND operator. We know that the result is only true if both of these operands are true. And because we already know that the first operand is false, it makes absolutely no difference whether the second operand turns out to be true or false. Regardless of that, the final answer is going to be false. So as Java is using short circuit evaluation, it stops evaluating the expression after it evaluates is age greater than 50. And that's because that part of the expression is false, which means that the overall expression's result is known and we don't need to waste time evaluating the second portion of the expression. Let's do another example. Suppose that we want to check to see if the height is bigger than 60 or the age is bigger than 40. Again, my first step is to fill in the value for my variables using the values from memory. So I'm going to check to see, is 70 bigger than 60 or is 25 bigger than 40? And now that I've filled in those data values, I can start evaluating the expression from left to right. I'm going to check to see, is 70 bigger than 60? That's true. Now let's think about how to combine values using the OR operator. The OR operator returns a true value if either or both of the operands are true. So because this first operand is true, we know that the final overall answer for the expression is true, and we don't have to waste time thinking about whether 25 is or isn't bigger than 40. It turns out that that portion of the decision is irrelevant because of the logic that's captured to make the decision. Let's do one final example. Suppose that we have the weight less than 180 and the age is greater than or equal to 20. So the weight, that's 150, so 180, and the value of the age is 25. So we evaluate the first expression, moving from left to right, and ask ourselves, is 150 less than 180? That is true. In this case, do we stop evaluating or do we need to evaluate the second expression? We need to keep evaluating to determine the final answer of this expression. That's because the AND operator will return true if both operands are true. So if it turns out this second expression is true, my final answer will be true. But if one or both of the operands is false, it returns a false answer. So if this second expression turns out to be false, then the final answer is false. So because the final answer depends on the evaluation of this second expression, Java will go ahead and do that. So we'll ask ourselves, is 25 bigger than or equal to 20? That is in fact true. And now because we are combining together two true answers using an AND operator, the overall answer is true. So in this case, we cannot stop evaluation after the first clause because the answer is unknown at that point. You might wonder why this turns out to be important. It's important to understand how Java approaches things so that you'll be able to effectively debug your own programs. One benefit of short circuit evaluation is that you can include a sub-expression to guard a potentially unsafe operation that occurs in a second Boolean expression. For example, suppose that you want to do something in your program if the result of a division operation is bigger than 2. And suppose the user is allowed to enter the numerator and denominator, or maybe the numerator and denominator are calculated elsewhere in your program. We know it's possible that the denominator could turn out to be 0. And if in fact that's true, then this particular operation, the division operation, is unsafe, meaning that mathematically there's no answer to dividing a value by 0. And if you try to do that in Java, it'll give you a runtime error that tells you that the result is unknown. And of course, that could be frustrating for somebody who's an end user and might not understand the error message that's displayed. So to guard against that happening as you execute the program, you could add in an extra sub-expression to make sure that the denominator is bigger than 0 before you bother trying to do the division operation. That would protect you from dividing by 0, because if the denominator is in fact 0, then as I'm evaluating this expression, I'm checking to see, is 0 bigger than 0? And the result of this expression bigger than 2? And when I evaluate the first guard to check to see, is 0 bigger than 0, I'm going to get a false value. And then I immediately know that the overall answer is false, and it doesn't even matter what I put in here as the second expression. Java will automatically stop executing before it attempts to do this unsafe mathematical division operation and crash your program. You can exploit the benefits of short-circuit evaluation to protect against unsafe operations in your program. It's important to know that Boolean operators also have an order of precedence, just like arithmetic operators. So just like we know that multiplication takes precedence over addition operators, certain logical operators and or and not operators will have precedence over other logical operators. Because you probably haven't encountered the precedence order for these logical operators in other contexts, it may or may not be worth your time to memorize the order now. I recommend that rather than memorizing the order, you use parentheses to impose your will. In other words, looking at this expression, result equals height greater than 30 or weight less than 20, and 20 is equal to the age, it's unclear which sub-expressions will be evaluated first. Will it combine together things using the or operator, or will it combine together expressions using the and operator first? If your intention was to have the expression represent whether the height was greater than 30 or the weight was less than 20 and the age was 20, then you would use additional parentheses around that and operation to make sure that that is evaluated first before you combine it together with the height comparison. On the other hand, if you're trying to capture the fact that the expression should be true if the person's height is greater than 30 or their weight's less than 20 and their age is 20, then you would use the parentheses around that first sub-expression to force that to be evaluated before it combines the result with the age comparison. So again, we might write that as result equals, we're trying to capture the fact that we want the result to be true if the height is greater than 30 or both the weight is less than 20 and the age is equal to 20. We would write it with extra parentheses around that second sub-expression. So that we make sure to combine those second two criteria before we bring them together with the or operation. On the other hand, we wanted the result to be true if either the person's height was greater than 30 or the weight was less than 20. We should put additional parentheses around that sub-expression to ensure that that's calculated first before we combine those things together with the comparison with the age. So either of those might correctly capture the logic that we intend to include in our program, and we just need to make sure that either we are using the extra parentheses to make sure that we are clearly communicating with the computer what comparisons need to be applied in which order, or we need to memorize the order of operations and then correctly build our expression using those. A final note is that when we're checking a single value to see if it's between a low point and a high point, we can't write it as a combined statement. Java will not compile a statement that says something like, check to see if 50 is less than some variable and that variable is less than 100. We can't write that as a single statement. Instead, we need to make two separate comparisons. Java is only capable of comparing the variable to one value at a time. So we need to check to see if 50 is less than something and that same variable value something is less than 100. Let's see what that looks like when we try to compile it in a program. So suppose we're making a Boolean value result, and we want it to be, we want to check to see if the height is between 10 and 100. If we try writing that as a combination statement, you can see that it's red and underlined. That's not going to compile. Java will give us an error message. See what it says. It says bad operand types for the binary operator less than. If we want to correctly write this expression in Java, we need to compare one value to our variable at a time. So we can check to see if 10 is less than the height and the height is less than 100. That will correctly capture our logic to check to see whether the height value is between those two endpoints. Later this week, we're going to learn about conditional statements where we'll use Boolean expressions to make a decision in our program. In the meantime, be sure to practice writing Boolean expressions in Java so that you can get used to the syntax and how the expressions are evaluated using order of operations and parentheses.